All right, inverse functions. Have you dealt with inverse functions before? Yes? Well, we dealt with them in this class when we did the inverse sine and inverse cosine, which means you dealt with those back in Math 2. But have you dealt with inverse functions besides sine and cosine inverse? Do you recall? Maybe, maybe not. If I wrote it up here. All right, I'm going to give you the big, long definition. We're going to talk about what it means and how to read when they're asking you to do things. All right, two functions, f and g, two functions, f and g, are inverse functions IFF. And that is not a mistake. Have you guys seen that before in mathematics? IFF, if, no? If and only if. No? You haven't seen it before? Yes? If and only if. Yes, it means it goes both ways. And let me continue writing and I'll explain. Two functions, f and g, are inverse functions if and only if f of g of x equals x and g of f of x equals x for every x. In their domain. All right. Okay, so the if and only if means two functions, f and g, are inverse functions if this happens, and if this happens, then they are functions. So it goes both ways, if and only if. All right, so if we can prove this, that means the two functions are inverses. If I tell you they are inverses, then this will always be true. Got it? All right. Questions on the IFF? All right. Does anyone remember how we write inverse functions? You guys remember that? And how do we say this? F inverse. All right. We are going to talk about domain and range and what happens with our functions. Are we ready? Okay, if I have a function f of x, and this is my domain, and this is my range, and I'm just going to make up a list of numbers: 1, 2, -3, 3, 4, 5. Then the inverse function then for your inverse function, what happens and what's nice is your domain becomes your range and your range becomes your domain. So what would the domain become? 3, 4, 5, and what would the range be? All right, 1, 3 is 3, 1, 2, 4, 4, 2, -3, 5, 5, -3. That is always true when you have inverse functions. Domain becomes your range and range becomes your domain. Is this clear? All right. Another note that should have gone up with the definition, I'm just going to add it here. A function and its inverse is reflected across the line y equals x. Okay, and that means they're symmetrical. They're symmetrical across the line y equals x. I am going to write more information here. Before I do, I just want to show you what that means. So here is our x and y axis. And here is my line y equals x. Do you guys agree that's the line y equals x? What's the y-intercept for the line y equals x? 0. What's the slope? 1. Now I just did a rough sketch, but can you see the intercept 0 and my slope would be yes? All right. So what it means to be symmetrical across the y equals x line is if I went up to here and drew half of a parabola, like so, instead of going up to for my inverse, what would I do? Right 2, and it would look like this. So you see how it would be symmetrical across the line y equals x. Yes? And that's true for all inverse functions. All right, the other piece of information I was going to write here is a function must be one-to-one to have an inverse. All right, what does that mean? We know what test to do to test if it is a function. How do we test if something is a function? Vertical line test. Now, everything that passes a vertical line test is a function. Do we agree? But not every function has an inverse. Okay, so we do the vertical line test to test if it is a function. And once it is a function, not every function will have an inverse. In order for it to have an inverse, it must be what? One-to-one. What does that mean to be one-to-one? Does anybody know? Have you guys done that before? All right, I'm going to use this picture here, and I'm working with pencil, so I'm going to be able to erase. So if you're working with pen, do not draw this piece in here. Okay, I'm going to draw the whole parabola. And if I do the vertical line test, is it one-to-one? Yes. I'm sorry. Does it not one-to-one? When I do the vertical line test, does it pass the vertical line test? Yes, which means it is a what? Function. Okay. So ignore this bottom graph. Is that graph there a function? Yes. All right. Now, the one-to-one you test using the horizontal line test. All right. Now, before we do the horizontal line test, when you do the vertical line test, that means for every x, there's only one y. Right? X cannot repeat. Yes? All right. Now, when you do the horizontal line test, you're looking for the same thing. It can't pass more than once. Does this pass the vertical or the horizontal line test? It does not. Do you guys agree if I draw a line, it's going to cross more than once? Yes or no? Okay. And that's why when I drew it originally, I only drew half. Why did I not draw the whole thing? Because the whole parabola is not what? One-to-one. And here's what happens if it is a parabola. If it's a whole parabola and I flip and I reflect across the y equals x line, I end up with this shape here. Okay, and again, I'm going to do some erasing, but I want to talk about why a parabola does not work. Because if I have a whole parabola and I reflect, I end up with this. And what can I say about this graph? It's not a what? Function. Do you guys see that? So in order for a function to have an inverse, it has to pass the what? horizontal line test, because if it does not, when you reflect, what's going to happen with your new image? It's going to not be a function. And that is why I only gave half. I only gave half because when I'm dealing with only half, does it pass the one-to-one horizontal line test? Which means when I reflect, does it pass the vertical function test? All right, does that make sense? Yes? Questions? All right. I am going to give you, in this little section here, steps on how to find the inverse. Steps on how to find the inverse. Number 1, change f of x to y. Step 2, swap your variables. Step 3, solve for y. Are we ready? All right. All right, number 1, find the inverse. Of f of x. Alright, and we are going to add more to this problem. Before I do, let's just work on finding the inverse. What's step 1? What is it? Change f of x to y. Y equals 2x minus 1. Step 2, swap the variables, so this becomes x equals 2 what? 2y minus 1. So all I did is I flip-flopped the x and the y. And the last step, solve for y. How would I solve this for y? What would I do? Add 1. And what do we get? 2y equals x plus 1. Divide both sides by 2. Now you can do individual 2's like that, or one big fraction 2. Totally up to you. Y equals like that or like this. Your choice. The second one, this one. All right, the only thing I ask that is you write it as f inverse. So instead of y equals, we're going to write it like this. F inverse of x equals x plus 1 over 2. All right. Okay. I am going to add more to the problem. Before I do, any questions, or was that pretty easy? Easy? All right, verify that f of f inverse of x equals x and f inverse of f of x equals x. Sketching we'll be doing on Monday. We're not going to be sketching them today. We're just finding this stuff and then verifying or proving or showing. Before I get into this verify piece, any questions on how we found the inverse? All right, so this was part of the definition, correct? f of g, but instead of g I now have the inverse. F of f inverse is x, and f inverse of f of x is x. So we're trying to prove this definition here, or show it, verify it. Okay, so I'm going to do the f of f inverse first. Do you guys remember composition of functions? Okay, I'm going to go slow, so I need you listening. F of, I'm just going to write down what f inverse is right in here. What is my f inverse function? The original one or the one I found? All right, thank you. X plus 1 over 2. And I'm going to take this f inverse function and I'm going to plug it into which function? The original. So you go to your original function, and you plug it in like so. 2 blank minus 1. 2 blank minus 1. What do I plug in the blank spot where the x used to be? Perfect. If you've got it, go ahead and continue. Would anybody like me to explain what I'm doing one more time? Okay. All right, if you've got it, continue. I'm going to explain again. All right, so I'm trying to verify this one right here is the one I'm verifying first, that it equals x. F of f inverse, and I'm going to try to verify that it equals x. So I just wrote down the f, and I took the f inverse, and in its spot I actually put what the x inverse is. X plus 1 over 2. So I just said, oh, well, I know what f inverse is. Take it out and put it in. And then I'm taking it and plug it into the original f function, which was 2x minus 1. 2x minus 1. 2 blank minus 1. I took out the x and put a blank, and what did I put in its spot? The x plus 1 over 2. What happens here with the 2's? And I'm left with x plus 1 minus 1, which equals x. Is that what we were trying to prove? Yes? All right, you do have one more, because we did this one. What's the other one we still have to do? F inverse of f of x also equals x.
Is this all one problem?
Yes. You don't have very many. I purposely gave you very little on this section. It's like even or odd, and it's like maybe there's not very many. And you'll go faster when you're working on your own. Now, some of you are probably done already because I'm explaining and going slow. All right, f inverse of, what do I plug in for f of x? The original, 2x minus 1. And I'm going to take the 2x minus 1 and plug it into which function? The inverse function. And my inverse function is here, blank plus 1 over 2. Blank plus 1 over 2. What do I put in the blank spot where x used to be? Good job. 2x minus 1 plus 1. What is 2x minus 1 plus 1? 2x over 2. What does that reduce to? X. And is that what we're trying to get? All right. Does that make sense? All right, number 2, I'm going to have you do the same thing we did up above. Are you ready? F of x equals x cubed plus 1. Before we go any further, do you guys know what the x cubed function looks like? Can you picture it in your head? Is it this one here? And is that function you're picturing in your head, is it a 1-to-1? Does it pass the horizontal line test? Yes. So it does have an inverse. All right. Again, we'll do more with the graphs next week, but for now, at least get a visual. Okay. Bless you. Let's go through the steps quickly. Y equals x cubed plus 1. What do I do with the x and the y? Switch them. X equals y cubed plus 1. And solve. I'm going to let you guys do that now. Subtract and get y by itself. So do you guys feel like it's hard or just takes a long time? All right. Did you guys get it? Did you subtract the 1 already? X minus 1 equals y cubed, and what did you do to both sides? Cube root. So y equals the cube root of x minus 1. Yes? And so y equals, not y equals, what am I going to put instead of y? F inverse of x equals the cube root of x minus 1. Do you guys remember what the cube root of x minus 1 looks like? It was the one like this?
Oh, the Egyptian?
The Egyptian one, correct. Good job. All right. Whew. So let's go ahead. So this is it. This is our first answer. Now we're going to do the verify piece. I'm going to start off with the f of f inverse. And I'm going to try to prove that it equals, or verify that it equals x. Okay. So I write f of, and I start with the inside. I change f inverse to what f inverse really is. And what is it? Cube root of x minus 1, and you're going to take this and plug it into which function? Into the f. Go ahead and do that now. I'll start you off. The f function is blank cubed plus 1. Plug it in. All right, did it work for that one? Yeah. What did you plug in the blank? Cube root of x minus 1, and it's raised to the third, so what happens there? And you have x minus 1 plus 1, which equals x. All right, and the last piece, instead of f inverse, is what? F inverse of f. All right, I'll let you guys try that one on your own. Did it work? F inverse, what did you plug in here for the parentheses? What is f of x? X cubed plus 1. Then you go to your inverse function, which is the cube root of blank minus 1. And what goes in the blank? X cubed plus 1. And what ends up happening? And I'm left with the cube root of x cubed, which is x. All right. Okay, again, you don't have a whole lot of these, but does it make sense? I have a question. Yes?
Are we always trying to find x?
You're not trying to find x. You're verifying that when you compose f with its inverse, your answer comes out to be x.
So it's always going to be x.
It's always going to be x. And if it doesn't, that means you've done something wrong, either in the composition piece or in finding your inverse piece, but somewhere there's an error.
Okay. When we give us like the problem, we're always going to be finding first like the inverse.
Yes.
And always start with
So find the inverse and then verify. So find the inverse was here. Here's the original, and here's the inverse, and then we did the work to verify. Yes.
So is it no solution if we graph it and it doesn't pass the horizontal line test?
When we get to the graphs, it's not that it's no solution, we just say the inverse does not exist.
Okay.
So it's a function, but it does not have an inverse, unless we have restrictions, which we will do eventually as well.
Can you explain like the one from
The horizontal, yes. So I am going to flip the page. when you're doing, that's going to come up more on Monday, but when you have graphs, I'm just going to use scratch paper for now. And they look like this, or like this. You're doing, first off, are both of these functions? Yes, because they pass the vertical line test. Are both of these one-to-one functions?
No.
No. Parabolas do not pass the horizontal line test. So this one, does it have an inverse?
Yes.
Yes, and it's that Egyptian-looking function you were talking about. Does this one have an inverse? No, the only way it would have an inverse is if we did what to the parabola? Cut it in half. Does it matter which half? It doesn't. One I showed you in notes earlier was only the right half, but you could pick the left half. Got it?
So it's kind of like the vertical line test, but horizontal.
Exactly what it is. Exactly. She said, is it kind of like the vertical line test, but now horizontal? Yes. So passes the vertical line test, a function. Both of these are functions. Passes the horizontal line test, has an inverse. Only this one has an inverse, this one does not, unless you make restrictions. All right, last piece of notes. Are you ready? Okay. Show that f and g are inverse functions. Algebraically. Okay, the book goes on to tell you to use a graphing utility to show blah, blah, blah. You guys know not to listen to that part, right? Obviously, because we don't use our graphing calculators yet. Okay. Number 1. F of x equals the square root of x minus 7 and g of x equals x squared plus 7, where x is greater than or equal to 0. So write it down and we're going to talk about it. Okay, what is the original graph? What does this graph look like? Square root. Last year, half of a
Parabola.
sideways parabola?
Yeah.
Do you guys remember that? All right, what does x squared plus 7 look like? A parabola, full parabola. Now, what did we just say about full parabolas?
Yeah, it don't pass horizontal.
So could a parabola be the inverse? And I said earlier, unless there is a restriction. And is there a restriction here? What is this restriction doing? Cutting your parabola in half. So now would it work? All right. So all we're going to do, I'm just going to go with the original with the f of x and go through the steps and verify. We don't have to plug in the x and yada, yada, yada. So find the inverse of this one now. Go ahead and do that now. Your steps. Change f of x to y and go from there. All right. Did it work? Can you guys tell me what you did from here? And what does that give us? X squared equals And what's the next step? Add 7, add 7. Y equals x plus 7 x squared plus 7. Did it work? Did we verify? Did we show? Yes or no? And that's it. You don't have to do all the other stuff. Yes. Questions?
So you just compared that one to the other?
So find your inverse and then compare. And if it works, you're good. You don't have to compare the other way.
Why would it
Because if it worked for this one, then when you do the work here, it's that whole if and only if, it goes both ways. You can, but it's not necessary.
So when would you do the other way if we're verifying?
If it told you this way, do f of f inverse and f inverse of f, you do both of them.
Oh,
All right, questions? Shall we do another one, or you guys got the hang of it? Got the hang of it? One more?
yeah.
All right. I'll let you guys go. Swap your variables and solve. Anybody have it? Did it work? Yes. What did you divide both sides? Oh, you changed your variables first, right? And what did you divide both sides by? Y equals 4 over, x over 4. So that's saying f inverse is x over 4. So is G the inverse of f? Yes or no? Yes? Yes.
Does it matter which one you choose?
It doesn't. It does not. Did you guys hear her question? Does it matter which one you choose to change? It does not. All right, we're good?